Hello everyone. So as discussed in this video, we will be discussing the pseudo code of Dijkstra algorithm. So let me draw a graph. Suppose this is the structure which we have considered into the last example where we discussed the algorithm. So the node 4 is connected with node 3 and 2 is connected to 3, 0 is connected to 2. Let's put some weights over here. 4, 8, 2, right? And suppose we have 6, we have 7 over here, we have 5 over here, right? And you got some, you might have some connection over here as well. So you can put words like 8 and 3. Okay. So this is like we have to find out from if it is like the source. So from source, we will try to find out the minimum cost for every nodes. And we discussed how we have done. So at the very beginning, we have we discussed like we need to understand that we will be having two arrays. Sorry, we have decided that we will be having two lists. One is visited, another one is unvisited. Now this particular star we can put through a Boolean array, and that Boolean array could be a single visited array. Initially, if we talk the size about this array, that is going to have the number of nodes this graph structure is having. So if it is n nodes, then the size of is going to have n. And initially every node is going to have false value. When it is visited, it is going to be with true. We can take another distance array. So distance is also will be a size of n, because we are having n nodes and we are calculating distance from the source node to every node. And as we mentioned in the last diagram, that this source is going to have initially 0, and except this everybody will be having infinite at the very beginning, right? So that we need to keep in our mind, that because and our prime motto is to take the minimum valued node. So if we pick it over, if we give 0 distance at the source, then comparing with other nodes, 0 is going to be the node which is having the minimum distance, right? So whenever we will be picking someone from the dist array, we will honor the minimum distance, right? So that's why we need to take this dist of source. You can say source is the index is equal to 0, and whatever we have said, the rest all other nodes is going to have infinite, right? Okay, so what is the next step, right? We will try to explain all the nodes except the node which is the source node, because it is having the minimum distance. And we will try to explore all the nodes, right? From the source. So we need a loop. So we are putting, so we can say like from the 0, we can go to n minus 1. Why? Because 0 has already been constructed. So till n minus 1 node, we want to explore every steps. So what are these steps? First of all, among the everyone, we need to find the mean vortex. So if we can say MV stands for mean vortex, then we can say we need a function or functionality which will give us find min vertex. So what do you mean by this min vertex, which is having the minimum distance? And not only that, it should be unvisited too, right? Sorry, it should be unvisited node too. So you need to check from the visited array whether it is visited or unvisited. But whenever you are considering it, that yes, I have eventually or finally got someone who is having the minimum vertex value, that means minimum distance value, as well as it is unvisited one, then we will honor this thing into the visited array. So you can say like the visited array MV index of visited array is going to be true, right? Because that is considered as a visited element, right? I hope till now everything is clear. What is the next step? As we have seen that whenever we have make someone visited, say for example 0 is visited, so we explored the adjacents of 0, that is here in this picture adjacents are 1 and 2, so we need to explore the adjacents. From adjacency matrix we can say like we will start j is equal to 0 and we will go up to n to find out who is the adjacents. So if j is basically is basically neighbor, so if j is neighbor of this min vertex, right, of MV, and whoever neighbor we are considering, which is j currently, and if that is not visited, right? So if it is not visited, then only we will consider j, right? If j is really fulfilling this condition, then we will go for a calculation that is distance via mean vertex, right? So we want to reach j. So basically what I'm trying to say, I'm just putting some word over here. We want to reach j, but via, but via mean vertex, that is MV. Okay. So how we gonna do it? Let's see. So you can say like distance via MV. Suppose this is the function we have read. Okay. How we can calculate that? So we have the dist array. From the dist array, we can say like distance of MV is what value we are giving, because we have calculated the minimum vertex already calculated. So distance via mean vertex is what? That we need to understand, right? Plus we need to add the distance, or we can say like weight of edge, weight of what? This edge, right? Weight of edge between mean vertex, that is MV, and j. Say for example, mean vertex initially is 0. If I just explain this thing, so dist MV will give us 0 because that is being stored into the, say dist source is equal to 0, and from the very beginning this is our MV, right? So that MV is going to be dist MV is going to be 0. So dist MV, that means 0 plus weight of the edge between MV here it is 0 to J. So J adjacence is adjacence of 0 is basically 1 and 2. If we consider 1, then 0 plus 4 is equal to 4. And that is going to be distance via MV, right? So that is what is exactly what it's the same thing. Suppose if you have calculated, so here it is 4, here it is 8. Next time when we are calculating, we will consider minimum of all these things who are unvisited, because 0 is visited. Next time when we will consider, you got my point. So between 1 and 2, who is going to be visited? 1, because that is going to have minimum value, because here 0 plus 4 4, here 0 plus 8 8, which is the minimum 4. So whenever we will consider 1 as visited, and whenever after that we will consider the neighbors of 1 who is also not visited, like 2 and 3 is not visited, 4 also not visited, then in case of 2, you can say the same thing. Distance of MV in that case is going to be 1, right? Because minimum vertex is, we have picked 1, and distance of MV is basically 1, and that 1 will have cost 4. So next time when we want to visit, so that is going to be 4 plus 2, that is 6, right? Who is basically minimum between 8 and 6? 6, so we will honor 6. We already discussed that thing in the last day. So whenever we got this distance, we need to store it, right? So, but we cannot store blindly. We need to pick some condition over here, and that condition is basically whether the distance we have calculated. So we are calling this function for an example, that is distance via MV. So it is giving us some distance, but we need to check that whether we will honor this distance really or not. So how we can ensure that we are dealing with minimum value. So if it is minimum, then the dist already existing dist value, right? Dist of J, right? So dist of J, if it is greater than this, that means if it is less than then we need to update the value. Update the value of this dist array. So dist array J value needs to be updated with this value which this function is returning. So distance via MV. Is that clear? So first of all, in this case, if we iterate for 0, 1, 2, the value is basically going to be 8, right? But next time when we consider 1, we can see like 4 plus 2. That means this distance via value is going to, via MV is going to give us 6, which is basically minimum between 8 and 6. 6. So that is going to be updated, right? Right. So we need to repeat this process, right? And we need to find out this relevant and actual stuff. So this is basically, we have not discussed this find minimum vertex stuff. So it is very easy, and we can do that in simpler way. So I think this can be solved. But yes, for the sake of simplicity, we can say that here we can use mean heap data structure as well. We can consider in this whole process to use the mean heap data structure, because that is going to make our program more optimized. So try to learn how this mean heap can be engaged over here and make this algorithm more efficient. Thank you so much.